Okay, let's move to our final experiment, that is 2-bit up down counter. Okay, in the experiment we usually design using JK flip flop. Okay, either up or down counter. So what make we will utilize both the JK flip flop in the IC7473. Okay, so the difference is that if we non-inverted output of the first one is connected, will give the clock to the second flip-flop. Okay, then it will be up counter, and if this inverted of the first one is applied to the this second flip-flop clock, okay, then it will be down counter. So let's see in the Tinkercad. Okay, we will connect two LEDs, and according to glowing we will see the what is the output, and we will also observe the output frequency of the first one and the second one output. Okay, so let's move to the Tinkercad. So just rename this experiment as a 2-bit counter, down counter. Okay, so first thing we need is breadboard. We'll again utilize our 840 pin breadboard. Now we need JK flip flop, that is IC7473. You can get it from logic section, that is 7473. All section, we will move to the logic section, and we can see here some inbuilt counter are also there. You can also see them, but we will design. Okay, what we usually do in our labs, that we are designing counters by using JK flip flops. Okay, so I have connected this JK flip flop here. Okay, we need power supply. Okay, first thing that is required is power supply. Okay, so here is the power supply. We will connect it according to our standard red, and this should be black. Connected to the other side also. This is the positive part. We connect it to the red, and this should be connected to the other side, that is negative side, and make it black. Okay, now the power option is at pin number 4, so connect it at pin number 4. Okay, make it red, and on the other side is ground, so connect it on the negative line, make it black. Now we need function generator to apply clock. We need function generator to apply the clock. The positive will apply to the this one, because this one is the clock one. Make it red, and this one to the common ground. Okay, so this should be connected at black. Now second thing is reset. Okay, so reset pin should be connected at, that is clear pin. You have to connect at high, that is up to VCC. Okay, this one is K. Both JK should be in toggle mode, so both K1 J1 should be at high. Okay, so we will connect it to the high. We will make this connection J1 and K1 at orange. Okay, so K1 at and J1 should be also connected to the high, make it orange. Okay. Now what is the next part? that is clock 2. Okay, now another section, according to the data sheet, we know that the another section is second flip flop. This is dual package of the flip flop. So the clock 2, to make the up counter, the clock 2 should be connected to the non inverted output. Okay, this is the output of first flip flop, so we will connect it to the clock 2. Okay, second flip flop के clock से connect कर दिया. Okay, make it pink, make it pink. Okay, now next pin is J RST2. This should be also connected to the high. This is a clear pin, and this one is J2. Okay, this should be also uh, connected in toggle mode, so it should be also connected to the VCC. Make it blue. We will make the color of both J and 2 and K2 in blue. Okay, so this should be also K2 should be also connected to the high supply, and make it blue. So here all of connection is completed, and let's come to the another side. Okay, J1 is connected, inverted output we don't need right now. Output 1 is connected, and the ground is connected, K2 is connected, and this is output pin. So all the input connection we have completed. Now we need two LED to display 2-bit output, two registers and two LED. One register, two register, and we need two LEDs. Here are LED 1, LED 2. So rotate all of them. Now rotate these registers also. Connect to the cathode part and connect another side of register to the ground. Make it black. Here in the second part also make it black. So the first output, okay, this is the output pin. We will connect this output to the first LED, and second output to the second LED, because output 2 will behave as MSB. Okay, and output 1 is behave as LSB. So now we can start our simulation. Okay, in the starting just change this frequency to the 1 Hertz, because it cannot go below 1 Hertz. Okay, let's start simulation. Okay, you can see 0 0 0 1 1 0 1 1 0 0 0 1 1 0 1 1. Okay, so this is the working of up counter. We can demonstrate the working of up counter. Okay, now what changes required for the down counter? We have to just change this clock line. We have to change this clock line to the non inverted output to the non inverted output to the inverted output. Just one thing, we have to click, we have to change the wire from non inverted output to the inverted. Now let's check the output. 1 1 1 0 0 1 0 0 1 1 1 0 0 1 0 0. So this is the working of down counter. So in this way we can demonstrate 2-bit up and down counter.